Hello 108 students, Mr. McHugh here. Welcome to Chapter 5, and we are going to work with exponents, and this is section 5.1. Integer exponents and scientific notation we're going to cover. In Chapter 5, if you look on page 263, we are going to talk about exponents, polynomials, and polynomial functions. Okay, so let's get started here. We're going to tackle page 1 here of our class notes, and we're going to deal with exponents. Hopefully for almost all students from 025, you feel comfortable with some of these exponent. We call them rules. I like to think of them as guidelines. Think of them, why would you want to go the long way or the hard way to do something when you could take a shortcut? And so think of these guidelines as shortcuts. And the first one's called product, means multiplying. What do you do if you multiply by the same base? Now, if we did not have shortcuts, you'd be required to take the definition of an exponent, which says take the base multiplied by itself 3 times. You'd have to write it out, x times x times x, and then take the next one. You get multiplication, x to the second, you'd write x to the x, and then you'd have to count 1 2 3 4 5 and say x to the 5. Okay, imagine if you had to do that all the time. That would make these problems extremely long and needless work being done. So, what's the pattern that you see? Look at the exponents, 3 and 2. Look at the results. What did we do? We added them. So whenever you multiply by the same base, keep the base and add the exponents. Okay. Practice saying the words. If you haven't gotten these in your head and you struggle with these exponent rules, practice the English version of the rule. When you multiply by the same base, add the exponents. And I only want to say this once because I don't want you to get this in your head. And here's the problem that students have trouble with is you're multiplying the base, you add the exponents. Please never ever multiply the exponents. I only want to see it once, okay? I only want to say it to you. So when you multiply by the same base, you have to add the exponents. Okay, that's requiring your brain to do 2 operations of looking at the same thing. So keep it straight in your head. Multiply by the same base, add the exponents. Okay, got a couple examples here. Once you've got that, let's just talk through a couple of them. Now you can see what's here. Multiply the coefficients. 5 times negative 3 produces negative 15. Now look at the base. Multiply y squared times y to the 4th. So you add the exponent. So y2 plus 4 gives you y to the 6th. And you're on your way. Okay, over here is another easy example here. Now I put this on here because, I don't see an exponent. What do you have to do? You have to mentally pop up the 1. We always assume the exponent to be 1 if you don't see it. So when you multiply by the same base, add them, 3 plus 1, and there's your x to the 4th. Okay, so here's an example. You got 2 variables. Whenever you see the coefficient in front of them, multiply them. 7 times 2 gives you 14. Okay, now how about p to the 3rd and p to the 5th? I've showed you detail work. Same base, add the exponent, result p to the 8th. How about q? I'll pop up the 1. 1 plus 2 is 3, and you've got your answer. Okay, you guys are getting the idea. This example here, whenever the bases are different, x and a y, you leave them alone. They are different bases. You cannot simplify anymore. Okay, objective number 2 wants to remind us 0 exponents. Anything raised to the 0 except for 0 equals 1. So anything raised to the 0 power equals 1. A note, 0 raised to the 0 is undefined. Okay, now this is one of these crazy little rules. We mentioned it here, and you might see it in a homework problem, but very rarely. It's just the one weird thingy that we have to remember. Okay, now here's a couple examples. Here's a number raised to the 0 equals 1, a variable raised to the 0 equals 1. Okay, now what I like to do when I go on the board here, I usually take an example as to prove, and we're going to talk about negative exponents. Follow this pattern. This is kind of like an informal proof. If I took 2, raised it to the 3rd, you would tell me 2 times 2 times 2 is 8. Okay, let's go and let's decrease the exponent and say 2 squared. Now you know the answer is 4, but this is what I want you to see now. I want you to see this pattern. If I took the previous result and divided it by the base of this problem is 2. The answer would be 8 divided by 2 is 4. Okay, now keep that in mind. Let's see if we can see this pattern. Now 2 to the first, anything raised to the first is always equal to itself. And does the pattern hold? Take the previous result, which is 4 divided by the base. 4 divided by 2 equals 2. Okay, so we've established this pattern. We must follow it now. This is one way to help remember that anything except for 0 raised to the 0 equals 1. Okay, there's the rule. You're probably going to memorize it, but why? Take the previous result, 2, divide by the base 2. What's 2 divided by 2? 1. There's where the proof comes in that anything raised to the 0 equals 1. Okay, now with that said, I like to continue here. Tell my students in class this is kind of like you're right on water, and now you're going to get a negative exponent, 2 raised to the negative 1. Now the question is, what does that equal? Okay, now let's put a pause on here. Our pattern tells us to take the previous result, which is 1, divided by 2. 1 divided by 2 is a half. Okay, now what we learn is we've learned a shortcut rule that allows you to tell you, and this is what I say in class. I like to say, when you see a negative exponent, we don't care for them. They're hard to grapple with. Positive exponents make sense. Take the base, multiply it by, Jizzy, stop it. Multiply by itself 3 times. That all makes sense. How do you multiply it by negative 1? Okay, it's a form of writing a fraction when you see a negative exponent. So what you realize is that you could take, anytime you see the negative exponent, write it as a reciprocal, 1 over 2, and change the exponent from a negative to a positive. Now 2 raised to the first is 2, therefore you get 1/2. Okay, now hopefully you remember how to deal with negative exponents. Mathematicians don't care for them, and they're hard for us to grapple. So how do we handle them? A couple examples. X raised to the negative 2. I put a little dash. You could think of that as being divided by 1. Flip it, write the reciprocal, 1 over x squared, and change the sign from negative to a positive, 1 over x squared. Now what happens if you get a negative a negative exponent in the denominator? Same idea, we don't care for it. So take it up to the other half and write it as y to the positive 3 divided by 1. Okay, hopefully these are all coming in okay. Here's an example of x raised to the negative 2 divided by y to the negative 3. Take x to the negative 2 is in the upper half. Numerator, take it down to the denominator. Change the sign from negative to positive. Take y to the negative 3, bring it up to the top, and change it to a positive. Okay, a couple quick illustrations of how to deal with negative exponents. You never leave answers in negative exponent form. Okay, a couple of them here. B's pretty good. I'm not going to cover that one. Look at this one. They put the parentheses around 5x, so the whole quantity goes down into the denominator. And once you're done with that, that would be what? Now, what's 5 to the third? Comes out to be what? 125. X to the third would be your final answer. Now look at the difference with this one. It's x to the negative 3 times a 5. You decouple them because of the multiplication, so the 5 stays up in the numerator. X to the negative 3 drops down into the denominator with a positive 3. Okay, now if you see this negative on the outside, you keep the negative 1. Think of the coefficient being 1 here, and then m taken to the negative 2 drops down to the bottom, and you make it a positive. Okay, hey, that takes care of page 1 already, so we're going to keep cruising here. I will see you for page 2 to continue on with exponents. Okay, bye.